This is a short worksheet that talks about the sign on the theta p. I've said several times that when you use the theta p equation for Mohr circle, it will give you the angle from the x face to the nearest principal. But I want to prove that to you. I want to show that to you. And so this is a synthetic example, kind of a made-up example to show you that that's true. So again, the theta p equation, if you use it properly, it always gives the angle from the Ix orientation to the nearest principal I, whether it's Imax or Imin. And the equation also gives the correct sense or direction. And so remember on Mohr circle, positive theta is counterclockwise, negative theta is clockwise. Negative theta is clockwise. Positive theta is counterclockwise. Sometimes you see the notation theta P1 is the angle to Imax, and theta P2 is the angle to Imin. And sometimes another term that's used is the major principle is Imax, or the minor principle is Imin. Terminology that you see sometimes. So again, this is the theta P equation we're talking about, and it's 1/2 inverse tangent minus Ixy divided by Ix minus Iy over 2. And if you always put in this equation in its exact form, and you always put in Ixy, however you found it, positive or negative, put in your Ix, your Iy, and whatever, this will return a number and a sign. And again, it will always take you to the nearest principal to your x. So I made up 4 cases. And so these are 4 different Mohr circles. For all the cases, I average is 10, is the center. In all the cases, the radius is 8. In all the cases, basically the 2 theta p is 40 degrees, or theta p is 20 degrees. And so I plotted one with Ix in the upper right, one with Ix in the lower right, one with Ix at the upper left, and one with Ix in the lower right. If these angles are all 40 degrees on the circle, then, and the radius is 8, then Ix at this location is 16.1 and Ixy is 5.1. If you put these values into this equation, you get theta p. You get 2 theta p is minus 40, or theta p is minus 20. And so the minus means clockwise. And that takes us to the Imax, which is the closest principal to Ix. If we plot Ix down here, which is 16.1 minus 5.14, and if you plug these guys into the equation, you get 2 theta p is positive 40, or theta p is positive 20. And so positive means we're going counterclockwise from x. And again, that takes us to the nearest principal, which is to Imax. If we plot Ix here, then its coordinates are 3.87 and 5.14. If you plug these into the equation, you get 2 theta p is positive 40, or theta p is positive 20. And so positive is counterclockwise, which takes us down to here. And this is the nearest I principal to Ix, and it's I minimum. Finally, if our x face plots down here, and we plug those, this is a negative Ixy, and this is a positive number here. If we plug these into our official theta p equation, we get 2 theta p is minus 40, or theta p is minus 20. And so minus means clockwise from our x face, which again takes us to our minimum. So this is just a really simple example that just illustrates that if you correctly put in your Ix, your Iy, and your Ixy into the standard theta p equation, it's going to give you the correct magnitude for theta p, and it's going to give you the correct angle from the current x face to the nearest principal I, either Imax or Imin, whichever one is closer to the x. It will take you to that guy. One of the reasons I like using Mohr circle for Imax and Imin, and if you correctly plot Ix, then it's just easy to see with your eyes which one that is. If you're dealing with the equations and you get theta p and you don't have Mohr circle in front of you, you can take that theta p and plug it into your transformation equations, and that will give you the I at that theta p. So you can always do that when you're dealing with equations without ever setting up Mohr circle.